Here's a number that's going to mess with your head. Scientists estimate there are around 2 trillion galaxies in the observable universe. 2 trillion, each one containing hundreds of billions of stars. And around each of those stars, potentially planets, worlds, maybe life. Now here's the stat that should stop you cold. Oxford philosopher Nick Bostrom calculated that if even one advanced civilization in all of that has ever run a computer simulation of conscious beings, just one, then simulated minds almost certainly outnumber real ones by billions to one. Which means statistically, the odds that you are one of the real ones are vanishingly small. Let that sit for a second. Okay, I know what you're thinking. This sounds like a sci-fi plot. And I get it. But I want you to stay with me here, because the people making this argument aren't conspiracy theorists or Reddit users at 3 a.m. They're some of the most respected thinkers on the planet. Elon Musk has said, publicly, that he thinks the odds we're living in base reality, meaning the actual, real, physical universe, are about 1 in billions. Neil deGrasse Tyson, one of the most famous astrophysicists alive, puts the probability we're in a simulation at 50-50. And the paper that started all of this serious conversation? It was written in 2003 by a philosopher at Oxford University named Nick Bostrom. It's called, Are You Living in a Computer Simulation? And it's been peer-reviewed, debated, and here's the thing, never actually been logically refuted. Not dismissed, not disproved, just never fully knocked down. So what does it actually say? Because it's not as wild as it sounds. In fact, once you hear the logic, it's kind of hard to argue with. And that's what makes it genuinely unsettling. So Bostrom's argument starts with a really simple idea. Technology gets better over time. That's just true. Your phone is more powerful than the computers that sent humans to the moon. And that was only 50 years ago. Now fast forward. Not 50 years, 1,000, or 10,000, or 1,000,000. At some point, a civilization advanced enough would be able to build a computer so powerful it could simulate an entire world. Not a pixelated video game world, a fully detailed, conscious, living, breathing world. With simulated people inside it who genuinely believe they're real. Bostrom says, fine, if that's possible, then one of 3 things must be true. And there's no way around it. At least one of them has to be right. Option 1. Almost every civilization in history destroys itself before it ever reaches that level of technology. War, climate, disease, something. They hit a wall and never make it. So the simulations never get built. Think of it like this. Imagine every civilization is driving toward a cliff. Option 1 says almost all of them go over the edge before they reach the destination. Option 2. Advanced civilizations do get the technology, but for some reason, none of them ever actually run these simulations. Maybe it's considered unethical. Maybe they just lose interest. Maybe something weird happens that we can't predict. But the simulators just don't simulate. That's like having the most powerful gaming PC ever built and never turning it on. Option 3. We are almost certainly living inside one of those simulations right now. That's it. Pick one. Because logically, at least one must be true. And here's the uncomfortable part. Options 1 and 2 both require something extraordinary to be true. Either almost all life destroys itself, or almost all advanced civilizations make the same strange choice to never simulate. Both of those are big asks. Option 3 just requires someone, somewhere, to have pressed play. Now here's where it gets really interesting. Because when physicists look at the actual, fundamental structure of reality, like really zoom in, they find some things that are odd. The first one is the Planck length. There is a smallest possible unit of space in the universe. You literally cannot divide distance any smaller than about 0.0000016 meters. Below that point, the concept of distance just stops making sense. In a video game, that's called a pixel. It's the minimum resolution, the smallest unit the screen can display. Below that, there's nothing to render. Our universe has one of those. The second thing is quantum weirdness. Here's something that genuinely baffled Einstein. At the subatomic level, particles don't have a fixed position until you actually look at them. Before you observe a quantum particle, it exists in multiple possible states at once. The moment you measure it, it snaps into one definite position. In computing, there's a technique called lazy rendering. It means Don't bother calculating what something looks like if nobody is looking at it. Only render the frame the player can actually see. Our universe seems to do exactly that at the quantum level. And the third one is the speed of light. Nothing in the universe can travel faster than 299,792,458 meters per second. Not because there's some physical wall in the way, but because that's just the rule. It's a hard limit. In computing, that's called a clock speed. It's the maximum rate at which the processor can update what's on the screen. Now, none of this proves anything. These could all be coincidences. But they're a strange set of coincidences for a universe that's supposedly just physics. The most common pushback people have is a practical one. They say, okay, even if it's theoretically possible, you'd need impossible amounts of computing power to simulate an entire universe. Atoms, molecules, billions of galaxies, every blade of grass, every neuron in every brain. That's insane. And yeah, fair point. But think about how modern video games actually work. When you're playing an open-world game, something like GTA or Minecraft, the game isn't rendering the entire world all the time. It only renders what your character can currently see. Everything else is compressed, simplified, waiting in the background until you look at it. Now apply that same logic to a simulated universe. What if it only fully renders the parts being observed? What if the rest, the distant galaxies, the bottom of the ocean, the inside of a rock, exists in a kind of low-resolution standby state until someone actually looks? That would dramatically reduce the processing power needed. And interestingly, that's exactly what quantum mechanics suggests is happening at the smallest scales of reality. But even if you throw all that out, think about this. Right now, in 2026, we can simulate individual proteins folding. We can model weather systems. We can run neural networks that mimic brain activity. And we have had computers for about 80 years. Imagine a civilization that's had computers for 10,000 years. Or 1,000,000. The processing power available to them would make our best supercomputers look like a child's calculator. Running a universe-scale simulation, for them, might genuinely be no big deal. Now, in fairness, most physicists aren't rushing to sign on to this idea. And the main reason is a word called falsifiability. In science, a good theory has to make predictions you can actually test. It has to be possible, at least in principle, to prove it wrong. That's what separates science from a just-so story. The simulation hypothesis, right now, doesn't really do that. Whatever you observe in the universe, you could just say, well, the simulator made it that way. It's a bit like a conspiracy theory in that sense. It can explain anything, which means it doesn't actually predict anything specific. There's also a more human objection, and I kind of love it. Every time humans invent a powerful new technology, we immediately wonder if the universe is secretly made of it. In the 1700s, when clockwork was the cutting edge, philosophers suggested the universe was like a giant clock. When steam engines arrived, some thinkers imagined the cosmos as a great engine. Now we have computers, and suddenly the universe might be a simulation. Maybe we're just doing the same thing again. These are real, valid criticisms. They matter. But here's the thing. None of them prove we're not in a simulation. They just show the idea needs more work before it counts as science. So let's say it's true. We're in a simulation. Someone, somewhere, built this. What actually changes? Your coffee still tastes the same. Your relationships still matter. The things that made you laugh yesterday still made you laugh. Pain still hurts. Love still feels like love. Philosopher David Chalmers makes this point beautifully. Even if we discovered tomorrow that we're simulated, the experiences themselves are real. The substrate doesn't have to be physical for the feelings to be genuine. But here's what it would change. It would mean the laws of physics are just rules someone wrote. It would mean that genuinely unexplained events, things that shouldn't happen, might be glitches or deliberate. It would mean physical death might not be the end, just logging off. And it would mean someone is watching. Whether that's comforting or terrifying probably says a lot about you. Here's what I want to know from you. If we are in a simulation, does it change anything for you? Does it matter? Or does the rent still need paying regardless? Drop your answer in the comments. Genuinely, I read every single one, and the best ones shape what I make next. If this gave your brain a good stretch, subscribe and hit the bell. There's a lot more where this came from. Next video, we're asking what actually happens to your brain in the seconds after your heart stops. The neuroscience is genuinely shocking, and it might change everything you think you know about what comes next. See you there.